Today we're going to be talking about Earth's interior. So first thing to understand is that Earth is layered. Earth is not a homogeneous, meaning the same all the way through. It's not a homogeneous structure, it is layered. Earth can be divided into different layers based on a couple of different criteria. One criteria is based on the chemical composition of the material, so what each layer is made out of. And another way to divide up the Earth's layers is based on the physical properties or the structure of the material. So first, let's look at the compositional layers. This is maybe a simpler way to look at it. Based on chemical composition, the Earth can be divided into three layers. The outer layer would be the crust, in the middle is the core, or the in-between layer. The second layer, is the mantle, and then at the very center of the Earth is the core. So let's look at the crust first. It's the outermost compositional layer. It's made of mostly rocks that have a medium to high silica content, which makes them less dense. It's the types of rocks that you're used to seeing, because most rocks that we interact with are the ones that are in the crust. There are two different types of crust which vary in thickness and density, and that is continental and oceanic. Continental crust is thicker and less dense than oceanic crust. It is primarily made of the igneous rock granite, and it can range from 30 kilometers thick to as much as 100 kilometers thick in mountainous regions. And continental crust also tends to be much older than oceanic crust. Oceanic crust is thinner but denser than continental crust. It is primarily made of the igneous rock basalt, and oceanic crust is only 5 to 10 kilometers thick in most places. It's also much younger than continental crust because oceanic crust gets recycled through the processes of subduction and seafloor spreading. And this is a process that we'll talk a lot more about when we get into plate tectonics, which is where we're heading next. And subduction is where one oceanic tectonic plate sinks back into the mantle, and it essentially gets melted and incorporated back into the mantle. And then seafloor spreading is the process of creating new oceanic crust at other locations along what are called mid-ocean ridges. And so this process keeps the oceanic crust relatively young by Earth standards. The oldest oceanic crust is about 200 million years old, which I know that sounds like a lot, but remember that the overall age of the Earth is about 4.5 billion years. So 200 million really is not that much by Earth's age standards. So here's the elements that can be found in Earth's crust. Remember that I said that Earth's crust is rich in silica, which is basically made out of two elements, and that is oxygen and silicon. So you can see that there's quite a bit of oxygen and silicon located in Earth's crust. That's the two most common elements. All right, below the crust is the mantle. The mantle is approximately 2,900 kilometers thick, and it makes up about 2/3 of Earth's overall mass. It is made up of primarily rocky material, but the rocks in the mantle have a composition that is lower in silica and richer in iron and magnesium compared to the rocks in the crust. This makes the mantle more dense than the crust. Density also is not the same throughout the entire mantle, but it actually increases with depth. So the deeper you go in the mantle, the denser the rocks become. And temperature and pressure also increase with depth. As you move through the mantle, and really as you move through all the layers of the Earth, temperature and pressure tend to increase with depth. Then that brings us to the core. It's at the center of the Earth. It's a sphere of metal that is 6,856 kilometers in diameter. It is made of mostly iron and nickel, those two metals, and it makes up about 1/3 of Earth's mass. Most of what we know about Earth's interior, including the size of the core, comes from studying how seismic or earthquake waves travel through the Earth. All right, now the other way that we can view the layers of the Earth is based on structural layers or their physical properties of the different layers. And this one gets a little bit more complicated because there's 5 different structural layers. The first is the lithosphere. The lithosphere is about 100 kilometers thick, and it consists of the crust and the very uppermost part of the mantle. The rocks in the lithosphere are cool and rigid, meaning that they can break under stress, which is what causes earthquakes. And the lithosphere is also broken up into different chunks or pieces, which we call tectonic plates. Below the lithosphere is the asthenosphere. It is a softer and weaker layer of the mantle. And due to higher temperatures and pressures, the rock in this layer is soft like putty, and it can actually flow slowly over time. The movement of this material in the asthenosphere is caused by convection, where the hotter materials down lower become less dense and rise, and the cooler materials near the top become more dense because of their cooler temperature, and that causes them to sink, and it creates these big circular currents within the asthenosphere. And it extends down to a depth of about 700 kilometers below Earth's surface. So here's a diagram to kind of show you these two things here. We have the lithosphere here at the top. You'll notice that in the continental areas, it gets thicker than in the oceanic areas. And then below that, you have the softer, weaker portion of the mantle called the asthenosphere. And then here's a diagram showing convection, how you have these this movement of material in the mantle. The red indicates the hotter material because it's closer to the core, and so as it heats up, it begins to rise. And then the material that's up here near the crust or near the lithosphere gets cooler over time, and so then it eventually sinks, and it creates these big circular currents called convection currents in the upper portion of the mantle. Okay, below the asthenosphere is the third portion of the mantle called the mesosphere. It begins about 700 kilometers down and extends to a depth of about 2,900 kilometers. And the rock in this layer is under much more pressure, which prevents it from flowing easily like the rock in the asthenosphere does. So this gives you kind of an idea of the relative thickness of these different layers. You know, right here we have the lithosphere, which is relatively narrow, only about 100 kilometers thick. Then the asthenosphere is about 700, and then or ends at about 700 kilometers down, and then the mesosphere goes from 700 kilometers down to about 2,900 kilometers. And then the last two structural layers are the inner and outer core. So when we're looking at differences in structure, the core can be divided into two parts based on its differences in its physical properties. The outer core is liquid due to the high temperature in Earth's center, melting the iron and nickel. The inner core is even hotter, but the intense pressure from all of Earth's mass above it prevents this portion of the core from melting, so it remains a solid. And then the last thing we're going to talk about today is Earth's magnetic field. First of all, how it is generated. So the movement of the liquid outer core as the Earth rotates generates a magnetic field. The magnetic field lines exit the Earth near the South Pole and enter the Earth again near the North Pole. And if you've ever actually used a compass that points your direction, the needle points to the north, the needle of a compass aligns with the magnetic field lines of the Earth, and that's the reason why it points to the north. Now, why is the Earth's magnetic field important? It's very important to life on this planet. The magnetic field helps to deflect the solar wind around Earth so it doesn't interact dangerously with our atmosphere. So what is the solar wind? Well, the solar wind is not literally wind like we think of wind. It's actually charged particles or ions that are ejected from the sun, and they travel through space at a very high speed. And these particles, if they were to actually come into contact regularly with our atmosphere, they would erode our atmosphere over time and thin it out, and basically it would make it to where Earth was uninhabitable. And so the magnetic field protects our atmosphere from these charged particles by deflecting them around the Earth so that they don't actually interact with our atmosphere. And this protection from our magnetic field has allowed life on Earth to develop and to survive for a long period of time. And then lastly, here is kind of a diagram showing this magnetic field in what's called the magnetosphere, where these charged particles represented here by these arrows are deflected around the Earth, and the Earth essentially is kept protected from those charged particles.